Now that we've covered the basics of what a CVE is, what a vulnerability is, and the CVE and National Vulnerability Database, let's look at some examples to help understand a little more. We're going to look at Heartbleed, Eternal Blue, and Log4j. Let's start with Heartbleed. Now, I'm going to bring you over to the CVE page for Heartbleed. And here it talks about it being TLS and DTLS implementation of OpenSSL 101 through 101G. Now, TLS, and we'll get to this in a little example, will encrypt data in transmission. Now, OpenSSL is the software that allows for that encryption, and for the private public key infrastructure that then leads to a shared private key. And it's in that utilization where we see what they're talking about here. There is a heartbeat extension for the packets, and it allows remote attackers to obtain sensitive information from process memory via crafted packets that trigger buffer overread, as demonstrated by reading private keys. That might not make a lot of sense, and I'll dig into exactly how it works and how you would take advantage of it, how you would exploit it in a minute. But let's continue to look at what research we have on this vulnerability. Now, National Vulnerability Database, it's a lot of the same information. You can see evaluator impact. This is new. This is helpful. And you got to take into account the nature of the data being protected, act according to the organization's risk acceptance. That's exactly what we talked about before, right? In risk management. This vulnerability, though it's got a high rank, 7.5, organizations will have to determine what they're going to do with it. It does not allow unrestricted access to memory, but it does leak information from memory. And that could include cryptographic keys and passwords. If you have the cryptographic keys and passwords, well, passwords are pretty straightforward, but the cryptographic keys mean that you could unencrypt all the traffic, which TLS is meant to prevent the eavesdropping and reading of data in transport. So that's not a good thing. We don't want that. Impact depends on sensitivity of the data and function of the system. There's a bunch of references, a lot of references, and includes some exploits and proof of concepts on how to use this. We'll actually look at a few of those. And then you have weakness enumeration, improper restriction of operations within bounds of memory buffer, and you could dive into exactly what that means. But here's the known affected software configurations, and it's just different versions of OpenSSL. Looks like some implementations in other software. And so that's worthwhile to look at and identify, are we using any of the software that is using that outdated version of SSL? We'll see this again in Log4j. It's a underlying system that other software might use. So it has long reach and a lot of potential impact. Now we can scan for this. You can find out what version of SSL is being utilized with this nmap script that will show which enum ciphers are being used. And there's an example down here. If we were to do our service scan, and then with the script SSL enum ciphers, we've looked at this in enumeration. And so if you're not used to using a script with nmap, go back and take a look at those videos and review those labs. And in this situation, it's going to be port 443 because that's HTTPS. There's other utilizations of TLS. This is just one of them. this would be an example of, hey, you found something, let's see if this applies and see if we can find a vulnerability. In here, there is TLS version 1, and that's not terribly helpful. It all depended on which version of SSL or OpenSSL was being utilized. So we can go even deeper. There's a specific script for SSL Heartbleed, and you can detect if a server is vulnerable to the Heartbleed bug. And again, it's going to look for TLS 1.0, 1.1, and 1.2. Let's look at it down here. And what we see is when it runs a scan, it comes back with, hey, this is vulnerable. It tells you a little bit about Heartbleed, it says it's vulnerable, high risk factor, and the description, it's using OpenSSL version 1.01 and 1.02 beta. So we can scan for that exact vulnerability to see if it's on a network. And you don't necessarily have to pick just one port. If you found a whole bunch of open ports and you know several of them are using a secured encrypted protocol, then you might want to run the scan against all of them. You could run it against all of them. If it doesn't apply, it'll skip it. Nmap scripts are usually pretty helpful that way. What we have here is eJPTv2, the exploit database. And you can see it's run by Offensive Security. It's a great tool that they put out for the community. And I've searched just for Heartbleed. Normally on eJPTv2, this is the first implementation here, it's just a large database. And if you take a look down there, 44,000 entries, and it gets updated fairly regularly. These last 3 in the last week of this recording. And it can be fairly straightforward to search for things. If I just type Heartbleed, we come across a few proof of concepts, and if you're curious what they look like, this one is a Python script. It looks like it's Python 2 or Python 2.7. It's not, doesn't look like Python 3. You don't necessarily need to know what all this code is doing yet. It'll be nice if you get there. But you could look at these proof of concepts and get an idea of, oh, okay, so if I run that scan, what is it doing? Because that's what this code is doing. It is just checking to see if it is vulnerable. It's not exploiting it. It's just saying, hey, is this vulnerable or not? So you can see what it returns. If it receives an alert and it is vulnerable, then we should see this warning. Warning, server returned more data than it should. Server is vulnerable. Now you might be wondering what all that means. Why is it returning more data than it should? Now let's return to our example. So we've looked at some of the data. If you came across a service that was utilizing encryption, then you might want to run some of those Nmap scans. You might want to run the Metasploit module that enumerates that. You might want to run an Nessus scan. All of those things can find whether it's vulnerable or not. Now, what does it mean? What does it look like when it is vulnerable? So you can run your Nmap scan, check for services. If you come across something that uses encryption, it might utilize that OpenSSL 1.01 to 1.01F Fox, and then you could utilize an actual proof of concept and run the vulnerability, exploit the code, exploit that vulnerability, and this is what it would look like. So the way TLS normally happens is we send a packet as part of the TLS handshake. So there's the TCP handshake, it sets up the connection, and then the next layer above that is the encryption connection. And as part of that, there's going to be public and private keys for either side that are going to encrypt a shared private key that is symmetric. And what's important there is to, as part of the TLS handshake, the client tells the server, hey, this is the password and the password is this length. And then the server itself is going to respond with confirmed, this is the password. And that confirmation, what it's sending back, is based on, I'll go back, that password length. Now, someone found that if you sent, here's the password, and the password length is, in this case, 52 instead of 12, then you could get back, hey, this is the password, and then in memory, whatever the next 40 characters are as well. And all of that would come back, and you would have to take a look at it. It's going to be in the packets. It's not necessarily going to be obvious. And the way that you craft packets to find this, you could use Scapy, you could use Python. There's Metasploit modules that take advantage of this, and exploits in the Metasploit framework that you can gather back the information you want. And it can go all the way up to 64,000 characters. So that you could pull pages of data. Thus, if someone were to find this vulnerability, then they could just keep asking for more information. And as the machine, the server, processes information, it doesn't always go to the same location. It's a buffer overread. And so depending on where in memory that variable that is part of the handshake gets stored, it's then going to read the next stuff. So it can be quite dangerous. You can get pages and pages of information from the memory of the server. And if the server is compromised and the client was utilizing a vulnerable version of OpenSSL, it could actually go the other way. So it's why even as attackers, or practitioners, we need to keep our systems up to date. And in this situation, it sends back information, and I cut it off after a certain point with some ... 64,000 characters. It's going to fill up the page way too much. And so that's how Heartbleed works. That's how it's utilized. And understanding that, you probably won't, hopefully, you won't see it in the wild on a pen test. But if you were to run something similar, now you know how to look for it in the National Vulnerability Database, and then in ExploitDB, see if there's proof of concepts, see if there's Nmap scans that can enumerate specifically that vulnerability. And that's crucial. We're going to see that again in the next vulnerability with Eternal Blue. So Eternal Blue is a very well-known vulnerability because it was part of a WannaCry ransomware attack. And it affected hospitals and organizations, governments all across the world for quite a time period in 2017. And the basis of it, there was a zero-day exploit that took advantage of SMB and SMB version 1 and a buffer overflow situation. It was alleged that the United States National Security Agency had known about this vulnerability, had created an exploit for it, and when there was insider threat and release of confidential information, their toolkit, including Eternal Blue, was released and then exploited by APTs as part of the WannaCry ransomware. And that affected so much of the world and seemed almost impossible to stop. Fortunately, a young researcher, Marcus Hutchins, found out what was the kill code, essentially, for the WannaCry virus. Because of the way that this vulnerability acts, it can easily spread throughout a whole ecosystem, especially since if one machine's vulnerable, other machines might also be vulnerable. Why? Why might they also be vulnerable? Let's jump in. So, CVE 2017-0143 It's SMB version 1 server in Vista Service Pack 2, Server 2018 Service Pack 2, and Service Pack 1. Windows 7 Service Pack 1, Windows 8.1, Windows Server 2012. Almost all operating systems being used at the time that weren't patched, and Microsoft didn't know until it got released because the US government didn't tell them. So it had to be found in the wild as part of that leaked toolkit from the NSA. And people just didn't update their service packs. It wasn't too hard to switch from Windows 7 Service Pack 1 to Windows 7 Service Pack 2, which mitigated this SMB version 1, but it's quite a vulnerability. Microsoft Corporation was the assigning CNA. Once they were informed of it, they shared the vulnerability with the community, and you can see some more white papers, some exploits and proof of concepts to take advantage of it. On the National Vulnerability Database, same information we see, and fairly high score. Now there's solutions, tools, proof of concepts, and the weakness enumeration, improper input validation for SMB version 1, and then affected software configurations, and there are versions of, yes, Windows 10, Windows 7, Windows 8 servers. This was part of Windows implementation, Microsoft's implementation of SMB. Now, this was, you could say it was the operating system. It was a service that was built and baked into the operating system and required a service pack or a patch or an update to the OS itself. It wasn't patched software that may or may not be running. If the operating system itself wasn't patched, then it was vulnerable. And it's such a ubiquitous vulnerability that it had far-ranging consequences. There is a specific Nmap scan for script to look for MS17010. That MS17010 comes from Microsoft's internal bug numbering system, and it's how a lot of exploits are talked about. MS08067 is another older one. You might see it in some courseware because the Net API, it also relies on SMB essentially, that same protocol suite, if you will, and a very similar problem, very similar exploit, very similar vulnerability, and very far-reaching. Again, part of the operating system. But also, if you want to explain how these vulnerabilities work, 6% of the time it works every time. So if you create a lab and you want it to work for your students every time, MS08067, MS17010 are really high up there for entry level. Hey, I just want to show you something and it's going to work. What this one looks like, it will test and see if it's vulnerable. It'll test that SMB connection, see if it gets back what it expects to get back if it was vulnerable, and it will tell you that it's vulnerable in CVE 2017-0143. Again, looking at exploit database, in this case for MS17010, there's some proof of concepts. There's some pretty good ones. There's some Metasploit code in here. This one right here says Metasploit. Let's take a look. It's the execution scanner. It's an auxiliary module. Sorry, this is Ruby. You're not expected to know how to read Ruby, but a lot of it's just plain English. And if you've worked with Metasploit at all, there's a whole course that Alexi has made that goes into how Metasploit and the framework and the modules all work together. The basis for Metasploit framework is Ruby, and so you should read through this code and see things that make a lot of sense, name description, author references. If you were to run info on a module, you're going to get this. It's going to pull it out of the Ruby and present it in the console. But looking through this code, we can see what works, what doesn't work. And if for some odd reason, maybe during a pen test, they don't want you to use Metasploit for some odd reason, you could see what is going on in the exploit module or in the auxiliary module. This is a scanner. And then perhaps recreate that in Python or Go or another language that's rather advanced. That's not going to be a requirement anytime soon in this courseware. Just wanted to give you an example of similar code. All right. Now, again, going to spill this out, exactly how Eternal Blue works. It's scary simple. So you scan your victim, and if it is Windows 7 Service Pack 1, if it's running SMB, if it is Server 2012, any of those vulnerable operating systems, then it's worthwhile to run that MS17010 script from Nmap. You might want to check to make sure it's a safe script, and because the exploit Eternal Blue can shut down SMB, and depending on what that system is used for in the network, shutting down SMB could be very bad. There's implications there. So understanding what those implications when you are exploiting a vulnerability is really huge as a pen tester. But we find out that it is SMB version 1 and it is vulnerable to Eternal Blue. So then what do we send? If you use the Metasploit exploits for it, it's going to send an SMB packet with a malicious payload. And what it does is it takes advantage of a buffer overflow inside of the SMB version, and then it can allow remote code execution. So in that payload, there's going to be probably, most likely, a reverse shell. That's what you're going to put in your payload more often than not. And what that will do is tell the server, tell your victim machine to call back to you and give you a shell, give you command line interaction with that system. And that's truly straightforward. It's very, very dangerous. Now, you don't necessarily need full command line access. You can run any sort of code. So if you have a virus, a worm that installs itself, installs ransomware, encrypts the whole system, and puts up a splash page of, hey, this is now encrypted and behind and up for ransom, and then also finds other systems on the network that also are vulnerable, and then sends the exploit to them, that's not very difficult code to write. And it will just propagate and keep doing the same thing over and over and over again. That's what happened, and that's why it was so bad. Because if one system on a network, and it was a flat network, got hit, if there weren't the right things in place, it spread across whole hospitals, it spread across whole communities, and quite a bad vulnerability. One that we still want to check for if you see old operating systems. Old operating system exists in operational technology in your ICS, your SCADA environments, often because they worked, and perhaps the software to run a system hasn't needed to update. It works. It pumps the oil out of the ground, and so it does that day in and day out. We don't need Windows 10 running the software that does it. It worked perfectly fine on Windows XP. And that's fine, but there needs to then be some segmentation and a lot of mitigation in there to keep something that you know is very vulnerable on your network. Because operational technology and information technology they touch quite often, and it's often overlooked. So that's something that we don't want to forget. Now, log4j, it's a library that's used for logging in Java. And let's take a look at the CVE page to kind of understand the jargony way of explaining it. It says Apache log4j 2.0 beta 9 through other versions have JNDI features used in configuration log messages and parameters do not protect against controlled LDAP and other JNDI related endpoints. I will break down what all that means. It is very confusing, but essentially an attacker who can control log messages or log message parameters can execute arbitrary code loaded on LDAP servers when message lookup substitution is enabled. I'll break that down a little bit. There's references to white papers, explanations. This is quite a big recent vulnerability. So much of the world, so much of gaming, so many web apps run off of Java that far-reaching impacts or possible impacts. We've already looked at this National Vulnerability Database page in the past lesson. There's a lot of information, a lot of affected configurations, and a very high criticality at this point. Just because without authenticating, only having access, if the old version of log4j is being implemented, all you have to do is run a very simple command and set up an LDAP server, which isn't that hard. And you could put malicious code onto the server. And depending on how the Java service is being run, you might have very high privileges when you exploit the system. And there's not too many ways to protect against it. Since it is so new, the Nmap script for it is still being developed. Many developers will come up with these things and then suggest them or propose them to, like Nmap in most cases, or Metasploit. Often put them up on ExploitDB, which we'll take a look at, though there isn't much up there yet. And you got to be wary about using scripts that you don't understand. You could read through some of this code if it makes sense to you. The NSE scripts are fairly straightforward. It's not a difficult, not difficult to understand. Difficult to write. Just like any programming language, I can read through it and know what a lot of it is saying if they made good variables and have good outputs. Writing it, that's another lesson for another course, another pathway. But in this situation, you can see the usage, what it would return in this situation. It's doing the log4j, log4shell.nsc script with some arguments, callback to a server, a remote LDAP server in this situation, on that port. And so it's going to test. It has this payload, this $, curly brackets, JNDI, colon, LDAP, colon, an IP address, a port, and then a file. And so in this situation, we had an HTTP proxy service running on port 8080, and it's going to send some GET requests and see what it returns. And you would have to take a look back at the callback server to see if it was actually vulnerable. But that's what it's going to attempt to run. Let's try to make sense of this vulnerability, because if you don't know Java, like me a week ago, it could possibly be very confusing. 84% of Java applications use log4j for logging. You would log your application. It could be messages, it could be bugs, it could be commands that are input, wanting to store those for debugging later if there is an issue. If it's a web app, you might want to gather information to see usage data. There's many reasons to log. It's a crucial thing for developers. And log4j is the library that you utilize for doing that with Java, and that's very common. On the slide here, we run our nmap scan and we get do our service enumeration. And what you return back varies. It varies so much. There's so much software that's utilizing Java that there's no way of like honing down and saying, okay, it is SMB version 1, it is these operating systems. Some things to look for are vulnerable web apps. It's Apache, so Apache Tomcat. Web apps run frequently on Apache Tomcat. You would see that in the service scan. It would say Apache Tomcat. There's also Jetty or Apache Tommy or Glassfish. These are other services used for web app serving. The web app could also utilize Java and be configured on a standard PHP website that's served up via Apache or Nginx. So you find a vulnerable web app or a vulnerable desktop application, truthfully. There's a lot of games that run on Java. There's a lot of desktop apps, just normal everyday apps that users use that are created with Java, and they have logging. And depending on how the system is used, that logging and usage of log4j could make the end server where those logs are being kept vulnerable. It could make the machine being used vulnerable. A little bit, if it is a desktop app, then you'd already have to exploit that machine to take advantage of the log4j exploit and then exploit that system. So that's something to take into account. But we find an input field. This is how it works. Java and log4j, it takes information from an input field. It could be a name. It could be username, password. It could be information that you send. For Minecraft, it was server chat. So someone stands up a Minecraft server and there's the chat functionality. What was sent in chat gets logged onto the server hosting the Minecraft server. Now, this command gets sent, and rather than the server parsing it as text and just logging it, it actually evaluates the code. And because of how this is crafted, its injection, it's going to get evaluated. Now, a $sign makes something a variable, and then this $, squiggly line, and then JNDI. JNDI being the Java naming and directory interface. It's going to then reach out for more code. This is useful for Java developers because you often want to make your web app or your desktop app as small as possible. Now, if you can keep code elsewhere and then reference it only if it's really needed, it does that. It keeps your software small and agile, and less processor, less things that need to be loaded into memory, less file storage space for storing your program, because it's going to utilize a server if it needs additional functionality. That's what JNDI and LDAP being the lightweight directory application protocol, that's the protocol used for interacting with a remote database. So in this situation, it's going to tell it, hey, reach out to, this should have been like malicious.ini on port 1389. That's going to be our LDAP server. It sees that variable. It does the lookup that says, hey, go look elsewhere. So we've got demo.ini down there, and it is an LDAP server that's served up on port 1389. Now, when they connect, they're going to look for a file called my code, and that's going to have a Java class in it. Java class is just Java code that is in another file. When it gets pulled over, it's going to get executed. So simple string in an input field made the server reach out and find more Java code. So a good example of this is here. It's Java. There's a lot that doesn't make sense to me. I mean, you can try to figure it out by reading it, but I wouldn't know how to write it. But if you get down into here, there's string and a command. And this might be small to read, but it says the command is bin sh tac c and then echo pwned redirected into /tmp /pwned. So what this code is doing, it's fairly benign, but it's going to run in bash, execute code of echo the word pwned and put it into a file temp pwned. And temp is rolled writable, so no matter what service is utilizing this, they'll be able to write to that file or create that file, write to it if it doesn't already exist. It's a little Linux understanding that if that doesn't make sense to you, go back and watch the videos and do the content on Linux. But we don't really need to understand too terribly much, just seeing that this is going to get pulled in to the Java application and get executed. That's what this class is. It's Java code that's pulled from somewhere else. Object-oriented programming, scripting utilizes classes and instantiates them. We'll get into that in a more advanced class, I'm sure. Actually, that understanding of object-oriented programming should be covered in the fundamentals course. So hopefully that makes sense. If it doesn't, go back and watch that. So it gets executed, and whatever code is there is going to be run by that server. In this situation, it's benign. Copy something into a file, but it could be a remote shell, a reverse shell, if you will. It could be almost anything. So it's terribly dangerous, potentially, to run code on another system unauthorized just from inputting one simple command into an input field and then having something ready on an LDAP server. And after creating some proof of concepts, it's not difficult to make a malicious LDAP server. This is a very simple exploit that works really well. I hope looking at the vulnerabilities and understanding what's behind them, how they apply, and then trying to think, how would you utilize this, playing the part of an attacker, being a penetration tester, being a red teamer. Hopefully this all made sense to you. If you're taking this course but you don't see yourself as a pen tester, you don't see yourself becoming a pen tester, you just want an understanding of cybersecurity, I hope this helped understand why these vulnerabilities are important. And start thinking about some of the mitigations. Even as pen testers, we need to think about the mitigation for these vulnerabilities, because that's going to go in our report, and that again is what is valuable and useful to the client. So with that, we're going to get into some labs.